Hello again, my lovely students. So we do have a third video on graphing sine and cosine. There is a reason for this. When we start graphing cosecant and secant, we're basically just going to graph the sine and the cosine and then sketch in the secant and cosecant based off of that graph. So this is going to graph 4 of the 6. You guys will have the Desmos activity that'll kind of like give you a kind of guess through of what the tangent graph could look like, and then you kind of reflect on it and check your answer. All right. So here, our try at number 8, they gave us the function g of x equals negative 0.8 cosine of 2x. All right, so our midline is again y equals 0. This has not been shifted. Our amplitude is 0.8, but we also have a flip positive y for negative y. So mathematically, I should say it's a flip across the x-axis or about the x-axis. But then I say that and like it gets confusing. So just up, down, or left, right. And then period, well, our phase shift is none, but our period our b value is 2. So our period is only pi. And then, so a normal cosine, let's zoom in a bit here. So a normal cosine would start at 1, go to 0 at pi over 2, negative 1 at pi, 0 at 3 pi over 2, and then 1 at 2 pi. All right, now, if I want to do cosine 2x, now I'm going to do that whole cycle. I'll still start here, but instead of finishing the cycle at 2 pi, I'm going to finish it at pi. So that means my half cycle will be there, and my quarter cycles will be there. So that's our main dots for cosine of 2x. Now, when we include that negative 0.8, the 0.8 is going to squash it slightly, but the negative is going to flip it. So instead of starting up here near 1, we're going to start down here just a little before negative 1, so a little above it. But then it will still go to this 0 point, up here to a little below positive 1, down here still to the 0 point, and then ugh. Now, if you're worried about your graph not looking that pretty, worst case scenario, label your points. So this point is 0, comma, negative 0.8. This point is going to be pi over 4, comma, 0. This one's pi over 2 and positive 0.8. 3 pi over 4 and 0, and pi negative 0.8. All right, so part of generating those numbers is just getting used to like adjusting the number, then you divide it in half again, and then average between the other two to get that third point. Okay, so there's our rough sketch, and we identified all the pieces they wanted. Taking a look at our next one now. So I deleted my graph paper for this one because the b value here is going to be annoying. So first, let me transform the function into the form I use. 3 sine, and then pi over 4 is our coefficient on x. So that is what we will factor out, minus the entire pi over 4 came out. So if I wanted to multiply back, I'd have to have a 1 there as a placeholder. All right, so my b value has a pi in it. So that means my period is not going to be in terms of pi, it's going to be in terms of numbers. So it'll look a little weird. All right, so let's start with that. Period equals 2 pi over b. So this is 2 pi over 4, which means we're going to multiply by 4 over pi. Pi's cancel. 2 times 4 is 8. So our period is 8 units long. We do also, though, have a phase shift. So we have x minus 1 . So that means it looks like we would go left 1, so we're really going to go right 1. If we were going to say what the h value is, though, the h value is technically a positive 1. Like the minus sign is considered part of the formula, kind of. It's weird. Even though I think I put the plus in my formula. If you guys lose points on that, let me know. I can go back and give you points on it. I grade the tests, but I'm saying on anything else. All right, our k is 0. There's no vertical shift, but our amplitude is 3. All right. So let's start there. Now we need some tick marks. So our period is 8 units long, but we have to start 1 to the right. So I want to start here. 3, 4, 5, 6, 7, 8, 9. So that is a period of 8 units between 1 and 9. Halfway between 1 and 9 is 5. Halfway between 1 and 5 is 3. Halfway between 5 and 9 is 7. So I divide it up like that because that's where our normal 5 points are on our sine or our cosine graph. Our midline and our extremes. Okay. So we have our phase shift and our period taken care of. This is a sine graph. So sine graph starts at 0. Then it's going to go up, whatever the amplitude is, back to 0. And the amplitude in this case is 3. So I'm just going to sketch in over here 3 and negative 3. Honest, it's 3. So down here, 7 will go to negative 3. And then on 9, we're back at 0. And then just, roughly curved close to the points. I'm more concerned about your points being like easy to read where they are, but not too big, and the line going close enough. If I can't draw a straight line, I don't hold anyone else to that standard. But that is a sketch of the graph. I'm showing one cycle, so that establishes the period, showing the start and the stopping point, that establishes the phase shift, and then my highs and lows to establish my amplitude, and then my midline, my 0 points. If there was a vertical shift, we would see that. So I'm going to skip this one. I'm going to skip the sketch. Let's talk about it, though. So our amplitude is 2, but that negative sign outside is going to give us that positive y for negative y, up, down, flip again. All right, and then our factored form, we're going to factor out pi over 3. we'll have x plus, what do I need to multiply to pi over 3 to get pi over 6? I need a half. So pi over 3 times 1 over 2, pi times 1, 3 times 2 would be pi over 6. All right, that goes back. So those are our numbers. So we have the amplitude number. Our period is 2 pi over the pi over 3. Pi's will cancel, the 3 will flip up. So this is 6. And then our phase shift is, it looks like it would go right, but really it's going to go left a half unit. So our period, instead of starting at 0, is going to start at negative 0.5. So I'm not going to do the whole sketch, but those period numbers can be a little tricksy. So negative 1/2. There's our left half from 0. Now I need to go 6 units bigger than that. So negative 1/2 plus 6 is 12 halves. All right, so we have 11 halves way over here as our end of the period. Now I need to know what's halfway between negative 1/2 and positive 11 halves. So when we're finding the halfway mark, that is our average point. So I would say 11 plus negative 1 is 10. Divided by 2 is 5, so 5 halves. Now halfway in between 5 and 11. So sometimes I'll kind of like do this in my head strangely. So 5 to 11 is 6, so half of 6 is 3, so 5, 6, 7, 8. We can also think 11, 10, 9, 8. So they're both 3. So 8 halves is really just the number 4. And then back this way, negative 1/2, if I go up half a unit, I'm at 0. 5 halves, if I go back half a unit, I'm at 4 over 2, which is 2. So halfway between 0 and 2 is 1. So that is our 4th number for our last. Those are the 5 numbers for where the marks are going to fall for the period. So you have to be able to produce those numbers to be able to label your graph. Now, if you're hand drawing your axes, then you just write the numbers in. Hey, you're done. It doesn't even have to like really be to scale as long as they are clearly labeled. So like here to here is 1. I could still say this is 2 and this down here is negative 2. So even though clearly my 1 unit right and my 2 units up look about the same number of pixels, that's okay. As long as it's labeled, doesn't matter. So this is a cosine, so it would flip upside down. So we'd go down, middle, up, middle, down. Now this one here, number 10, actually has a number for all 4 things. But again, our B has a pi in it again. It makes it easier to graph on normal paper, but you still have to do all the mess with figuring out where the period starts and stops. So I don't know how much that is really doing us a favor, especially since most of the time you use trig functions to model angle rotation. So your input is an angle, so you wouldn't be multiplying by a pi because the angle has a pi. All right, so another negative 2 cosine. Now if I factor out pi over 2, that would leave me with the x I want. I have factored out the pi, so I need to ask myself, what would I have to put here so when I multiply pi over 2 times this thing, it will give me a pi? And in that case, it's the number 2. So pi over 2 times 2 over 2 and 2 would cancel, and we'd have pi left, which is where we were before. and then plus 3. Now notice in my factored form, there's 2 sets of parentheses. So the inner one for where I factored, and then the outer one so that everything that's inside cosine is labeled inside the parentheses, and that plus 3 is outside the parentheses. Most of the calculators, if you forget that second parenthesis, but you didn't have anything else in the equation, it'll do it, it'll graph it. But if you did have that plus 3 and you didn't close the second set of parentheses, it will graph the wrong thing. All right. So let's label some stuff. So our amplitude is 2, and we have an up-down flip. Our period is 2 pi divided by pi over 2. So pi's will cancel. Divide by 2 is the same as times 2, so our period is 4. Our h value is -2 because x plus 2 looks like it would go positive x, but it's really going to go negative x. So left 2. And then our outside number at the end, this is our graph that our number that takes it and moves it up or moves it down. In this case, plus 3 is going to take the whole graph and go up 3. So I like to see, like when I'm going to graph, I like to know what all 4 pieces are and if there's any flips. So that way I know I'm going to graph what they want me to graph. Not what I wanted. Of course. Nah, no big deal. So, all right, so our period is 4, but we're going to start 2 to the left. So 1, 2, now that would go 2, 3, 4. So that's going to be 1 period. Instead of starting at 0, it starts at -2. And then -2 plus 4 is +2. So this is in between marks are 1s and 0. All right, so that took care of our period and our phase shift. Now our up 3, give me a sec, I gotta shift the whole thing. And see, if you're doing this on graph paper, it's not as bad. But when you're doing it here, it gets to be, so that's like R3, but then we're gonna have to go the amplitude higher than that. So that's why I moved it all down, because our graph will actually end up being completely above the x-axis. All right, and then you can, what I like to do whenever I have a vertical shift, is I like to mark that midline, the 0 line, with a dashed line. So that kind of reminds me, like when I'm graphing sine, I'll start on there, I'll go up, go back to there, go down, come back. Or cosine, I start above it, hit it, below it, hit it, above it, unless I have flips or whatever. And then we were calling this the midline. And in this case, it's always a horizontal line, so it's always a y equals line. In this case, it's y equals 3. All right. So taking care of that, now I just need to take care of my amplitude and the flip. So cosine normally starts up, but since it has a flip, it's going to start down. So it's going to be 2 below the 0 line. Then our next horizontal mark will be where it's on the 0 line. And then over here, it's going to go all the way up at 5. Here, back to that 0 line. And then that 2 is going to be at 1. So not the prettiest, but it's there. Now here, the points are actually all like nice. This one is -2, 1. Then this one is -1, 3, 0, 5, positive 1, 3, and 2, 1. So take some practice getting used to sketching the graphs, but you are eventually going to have to produce one, just not on exam 1. It'll be on exam 2. We're going to have a whole lot of other stuff there, so get this under your belt now so you're really comfortable doing it. And getting used to adjusting the periods, like that's a usable skill we can use as well. All right, so this last one here is actually a word problem. It's not horrible. So for some weird reason, we have a weight attached to a spring that is hung from a board. So this is under the board. Where are they going? Boing, 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 boing. Yes, that was just an excuse to make the sound effect. So as it oscillates up and down, the position y of the weight relative to the board ranges from -1 inches at time x equals 0 to -7 inches at time x equals pi below the board. Assume the position of y is given as a sinusoidal function of x. Sketch a graph and then find a function that will give you that graph. All right. So at x equals 0, we are at -1. At x equals pi, we're all the way down here at -7. So that is our high point and our low point. So our 0, our actual x-axis here is the board. Okay, so if I range from -1 inches to -7 inches, that is 6 units in between them. The amplitude is going to be half of that. So our amplitude is 3. Now this was one extreme to the other. So if I go that same amount of units, pi units, I'm going to get back to my other extreme. Because one extreme to the other is half of the period. Or a 0 point to the next 0 point is a half a period. All right, so that is like our highs and lows. So now we just need to figure out halfway in between -1 and -7, 2 and 6, 3 and -4. All right. So this tells us that our k value is -4 because that's where the 0 line would be. And that also tells us at pi over 2, we would have a point down here at -4. And at 3 pi over 2, we would have a point down there. So there is enough to sketch the graph. Our period is 2 pi. So that means the b value is 2 pi over the period, but the period is 2 pi. So it's 2 pi over 2 pi. So it is 1. And then this starts at a high point on the y-axis at x equals 0. And that is the same thing that the cosine graph does. So there is no phase shift. All right, so I have A, I have B, I have H, I have K. I have enough to write this. Y equals A cosine B x minus H is 0 plus -4, so I'll just write -4. Now that has some unnecessary numbers, so if we clean it up some, y equals 3 cosine of x minus 4. The only reason I put the parentheses in there at the last moment was so it didn't look like it was supposed to be x minus 4 inside the function. So when I put the parentheses there, it's very clear, no, I'm deliberately writing that 4 outside the function. Some books will instead write the minus 4 in front of the whole function, and it'll be negative 4 plus 3 cosine x. Just to be very clear, there's no way it's inside the function when it's all the way in front of it. So that is all of our graphing for the sine and cosine. So enjoy playing with those. Start thinking about what tangent might be. I'll see you guys on the next one.